Hello, this is the Law of Signs lesson. You should be listening to this with your notes packet out and have the heading Law of Signs lesson. Next two lessons we're going to be talking about the Law of Signs and the Law of Cosines. These are two different formulas, I guess you could look at them as formulas. These two formulas help you to solve triangles. And as I wrote in your packet, solving triangles boils down to finding all three angles and all three sides of a given triangle. Sometimes you won't have to find all of them. Sometimes you'll just have to find a specific one. The key thing, once we know both of these rules, law of signs and law of cosines, is to figure out which one to begin with. Today we're just going to be talking about law of signs, so it's going to be obvious that that's what we are going to be using because we don't know the other one yet. But I wrote it out in more detail in your printed notes. But basically, you're going to use law of signs anytime your given measures have an angle and a length of a side opposite the angle. That's going to be law of signs. And so I wrote out some more details about that in your printed notes. And then if you're given three sides, or if you're given a side, then an angle, then a side in that order, you would be using what's called law of cosines. And we'll talk about that in our next lesson together. In your packet, I drew out 4 triangles for you, and I want you to highlight here what I mean by each of these kind of labels. Side, angle, side means that you're given 2 sides with an angle between them. So you'd have a number like, say, 14, 10, and 22 degrees, something like that. You're given a side, an angle, and a side. The angle's in between the 2 sides. Now, those don't have to be the particular numbers, but side, angle, side does mean that you're given 2 sides told to you as numbers and an angle in between them. Now contrast that with angle, side, angle. That's the next one over here. Angle, side, angle means you know this angle, you know this angle, and you know the side that's in between them. Okay, angle, angle, side. This one is often confused with this one because if you look at the little abbreviation here, angle, angle, side has 2 A's and an S. This also has 2 A's and an S. But angle, angle, side is different because if you look at where the angles are relative to where the side is, this is angle, angle, and then the side isn't between the angles. Over here, the side is in between the 2 angles that you're told about. Okay, so that's the difference. And then side, side, angle is when you're told numbers for 2 sides and then an angle that isn't in between the 2 sides. And if you contrast that with this one, okay, this one has 2 sides and an angle. This one has 2 sides and an angle. But in this first one, side, angle, side, the angle is in between the 2 sides, both in the name and in the picture. Now, depending on what you're given, the information that you're given is going to tell you if you use law of signs or law of cosines first. And our preference is very much going to be for law of signs because that's far easier. This is a law of signs situation because we are told an angle and a side that are across from each other, and that's a necessary condition for using law of signs. And this guy is also law of signs because we could remember that triangles have to add up to 180 degrees. So we could find that missing angle, and then we have an angle and a side that are across from each other. This case here, this side-side angle case, is a tricky case because although you have a side and an angle across from each other, this sometimes causes some problems because side-side angle, if you remember from geometry, is not a triangle congruence theorem. So this is a tricky case that we won't spend much time on at all, okay? The side angle side case in the upper left is going to require law of cosine. So we won't be doing any problems that start with 2 sides and the angle in between them today. We'll be doing that in our next lesson. Okay, sorry, that long pause there was me thinking I had put pause on you, but I had not. I was just thinking. So these next questions don't match up exactly with your handout, but I would like you to just think through them, and then we'll go back to the 2 questions I typed onto your page. Which of the following situations would lead to a set of congruent triangles? Is side angle side a congruence theorem? And yes, it is. Okay, if I know this side and this side are congruent, this side and this side are congruent, and this angle are congruent, that's enough to say that those triangles, the entire shapes, have to match. Then the next one, angle, side, angle. Yes, that is also a congruence theorem. Two pairs of congruent angles and then a pair of congruent sides. Angle, angle, side, in fact, is also a congruence theorem. But this last one, side, side angle, is not a congruence theorem. And this is just a more specific way of pointing out why I was mentioning that one case as being really, really tricky. There are two questions that I asked on your page that I didn't type onto here. I'm not really sure why I did that. But I asked you, do all sets of three sides form triangles? What do you think? Well, if I gave you this little stick, and then this little stick, and then this big long stick, could you put them together to make a triangle? Well, we could try, right? We could take these little pieces and maybe put them on the ends here. Would they connect to make a triangle? No, they would not. So the answer to this one, that's printed on your page, is no. Not all sets of three sides will make a triangle. And then the other question I asked you is what has to be true of all three angles? The three angles together have to add up to something. What do they have to add up to? 180 degrees, that's right. Okay, so all three angles in a triangle have to together combine to equal 180 degrees. Okay, keep those things in mind, and here is actually the statement of the law of sines. I tend to favor this version, but either version is fine. They are equivalent. And it says that if ABC is a triangle with sides little a, little b, and little c, and we have talked about this in the past quite a while ago, that if you have a triangle, you label the corners with capital letters, and then the sides get labeled based on what they're across from. So capital A and little a are across from each other. That means that little b is over here, and little c is over here. So the lowercase letters represent the lengths of sides. The capital letters represent the angles. So if you have this sort of setup, then this statement that I've highlighted in green over here is true. You really will not use all three parts of this at once. You would use maybe this fraction and set it equal to that fraction, for example. That way you'll have a proportion. Something like this. And you'll fill in the numbers that you have, and then you'll solve for the number that's missing using cross multiplication and some other things, okay? Here's our first problem that we're going to do together. If you don't have your calculator out, I invite you to pause this lesson and get your calculator, because you do need it. And in fact, once you have your calculator, please make sure that it looks like this when you push mode, okay? You'll see that the red mode button is highlighted here, and we're on degree mode. That is definitely what we need for all of these problems, okay? All right, hopefully you're ready with your calculator, and let's first start out with drawing this picture. It says that angle A is 28 degrees, so I'm going to draw something that looks like a nice little acute angle. Call it A. Angle B is 45. So I'm going to make this one my angle B. And side C is 120 meters. I know it's a side because it's a lowercase letter there. And so this is 120 right here. Now I noticed that my given information fits a certain pattern. It fits the pattern of angle, side, angle. And in the introduction, I remembered hearing that that meant law of sines. Okay, now this is sort of a silly step today because you don't know the law of cosines yet, and so everything's going to start law of sines, but I do want you to be in the habit of labeling, which one you're starting with. I'm also going to encourage you to label in your picture the things that are missing. So you see that I just labeled little a and little b respectively. Now I am going to see if I can figure out where I see a side and an angle that are across from each other, and I know both numbers. Well, it's not B because little b is unknown. It's not A because little a is unknown. So it must be that I can figure out what this angle is. Okay, that angle is going to be found by taking 180 degrees, which is the total number of degrees in a triangle, and subtracting what 28 and 45 make together. So that is 107. So I know that this missing angle is 107 degrees. I will write that into my picture. Now I'm going to use the law of sines. I know that the sine of my angle, which is 107, divided by the side that's across from it, so that would be 120, has to equal, and now I'm going to write sine of 45 over b. So the two parts that I was using were the parts that were across from each other. That's what you want to look for in law of sines. This pair and this pair, okay, across from each other. Once you have this set up, then it is an algebra problem. You will cross multiply 120 sine of 45 equals b times the sine of 107. And then I'm going to divide both sides by the sine of 107 degrees. These will cancel out, and I will get that b is whatever this part on my calculator tells me. 120 sine of 45 over sine of 107. So let's see if I can make this a little bit smaller. Maybe not. Hold on a second, I'll see if I can do this. Okay, there it is, that's what I wanted to do. Okay, so I'm going to take 120 times the sine of 45. Okay, and then I'm going to divide by the sine of 107. Remember that I did put this into degree mode. These angles are measured in degrees, not radians. And so B is approximately, I just lost my calculator, 88.7, let's say 730. 3 decimal places is definitely more than enough for us, okay? So once I know this side, then I should be able to figure out the other missing side, again using law of sines. I can't use Pythagorean theorem here. Can you guys think of why? Why can't I just say this number squared plus 120 squared equals this number squared? If you answered yourself that it's because it's not a right triangle, that is awesome. Good for you. That's exactly why. Okay, now I'm going to finish this up with another application of law of sines. Okay, so sine of 28 over the missing side, little a, has to equal sine of 107 over 120. Now you might ask, why didn't I use sine of 45 over that number we just found, 88 point such and such, right here? But the reason I'm not doing that is because these are cleaner numbers. Furthermore, what if I got this wrong? What if my b value is wrong? I'd be spreading the poison. So I want to stick with things that were in the problem as much as possible so that I don't kind of spread a mistake if I have one. Okay, I'm going to divide both sides by sine of 107 and find out what a is. So I'm going to bring my calculator back up. That's not the calculator, that's the calculator. Bring my calculator back up, and now I will type in what we've got here. So 120 sine of 28 divided by the sine of 107. Oops, I have a typo there. Let me try that one more time. Oh, I have a typo there. This is a bad typo day for me. Trying to hurry too much, I think. Okay, there we go. Good enough. Hopefully that'll take. It didn't because I had an extra parenthesis. I was hoping it would go. Okay, so 58.9. We'll go with that. Very good. Okay, and we know that we've solved the triangle if we have found all the missing sides and angles, and we have. Okay, next example. Okay, my picture should have magically have just appeared, and we're going to set this up again using law of sines because I see here that I have a side and an angle across from each other. So that will allow me to apply law of sines. So sine of 63 over 12 is going to equal sine of 38 over little b, and then we will cross multiply to get this. Our next step is to divide by the sine of 63. And so we should have this. And then we're going to pull up the calculator and hope that I can type a little better this time. Good grief. Okay, so we'll have 12 times the sine of 38. And we will divide that by the sine of 63. Okay, 8.291. Okay, so we just figured out this side. Okay, we should be able to figure out the missing angle up here pretty easily. That's a good one. Okay, 63 and 38 is 101. And so if we take that away from 180, we should get 79. That 79 should allow us to find side C, and then we are done already. This is a quick one. Okay, so we'll say sine of 79 over side C equals sine of 63 over 12. Again, notice I'm using the given here, not the thing that had the 8.291 blah blah, in case it's wrong. Okay, don't spread the poison. So 12 sine of 79 equals C times sine of 63. This is what I got for C. Okay, so that's example 2. I hope it's making sense. Here's example 3. Okay, take a minute. Why don't you pause this and see if you can come up with the picture on your own. Okay, here's an example of how your picture might look. Notice I drew A very large. That is because 130 degrees is an obtuse angle, and so I wanted to represent that correctly. And I'm getting pretty excited here because I have an angle and a side across from each other. So that seems to me to be law of sines. And so then I'd have sine of B is across from little b over here. And we're going to try to solve for that missing angle. Now we haven't had this case yet where we're missing an angle. So let's see what happens, okay? 1.3 times the sine of 130 degrees has to equal 1.2 times the sine of angle B. This is not a problem. We're just going to divide both sides by 1.2, and we'll get this expression here. Okay, because these 1.2's on the right side will cancel out. So I know that the sine of B has to equal what I'm going to get when I do 1.3 times the sine of 130 over 1.2. Now something pretty interesting is about to happen with this problem, okay? So we're going to just try this out. 1.3 times the sine of 130 degrees divided by 1.2. Okay, so I get 0.82988, etc. Okay, so you can see I've written this down, and so now remember back when we did calculator stuff. To get just capital B, I need to inverse sine the other side of the equation. So B is going to be inverse sine of 0.82988, etc. Okay, pull your calculator back up, and we'll have to do the inverse sine of the previous answer. Okay, rather than typing in that whole decimal, I'm just going to use the previous answer feature on the calculator, and it takes all the decimal places. Okay, so now that tells me that angle B, the calculator thinks angle B should be 56 degrees. Now if you check that out, something weird happened here, because 130 plus 56 is too much. That can't be. The angles in a triangle have to add up to 180 degrees. So look at this picture again. Which case is this? This is the case where we have given to us this side, and then an angle that isn't in between them. Remember I said that side-side angle wasn't a triangle congruence theorem? That's the tricky case. Furthermore, if you kind of think about it physically, 130 degrees is going to be the biggest angle in this. So shouldn't this opening be the largest number? And 1.2 is less than 1.3. So that, this just can't happen. In reality, if you measured this out, there's no way that you could have a side that is 1.2 and this side be 1.3. There's just no way. So this is a case where the triangle doesn't exist. No such triangle exists. No solution. No solution. Okay? So that is what I would want you to note on your paper. If you run into something where things are falling apart, you just say, hey, this triangle can't happen. Okay. The next little piece of your notes has an area formula. Okay, and we're going to end off with this. You know other ways of finding area of a triangle. You know that you can find the area of a triangle doing 1/2 the base times the height. And that's all fine and good if you know the base and you know the height, which is this dotted line, or the altitude, of the triangle. So if you know the height and the base, that's great. But sometimes that's not what you're given. Sometimes the things that you know don't match up with that. Well, from the law of sines, a different kind of area formula can be created. And I'm not going to go through how it was created, but I'm going to tell you it is related to the law of sines. And you have it there in your notes. It's 3 different versions because it depends on which angle you're given. But here, you see that I've written it as 1/2 BC sine of A. So if you have a triangle where angle A is a number that you know, and then side B is something that you know, and side C is something that you know. That means you know numbers for this, and this, and this. Side, angle, side. Then you can use this area formula. And then there's other versions depending on, maybe you know angle B. Well then, A and C go right here, the sides, and a 1/2. Or say that you are given angle C. Well then A and B go right here as well as a 1/2. So any of these are a way to find the area of a triangle if you're given side, angle, side numbers. All right? So here's example 4. It said find the area of the triangle if angle C is 102. So here's angle C. And then you're also told, this is an angle, you're also told that A is 90. So I'm going to make that 90, which means this is A across from it. And B is 52. So I am given a side, angle, side sort of picture. And the angle that I know is C. So I'm going to use this version up here that I put in red, that exact same thing. So area is 1/2 times A times B times the sine of C. And this is just plugging stuff in, you guys. It's awesome. So area is going to be 1/2. Little a is 90. That's here in my picture. B is 52. That's here in my picture. And the angle in between them is 102. Okay, and that's measured in degrees. So when I'm on my calculator, I would have to make sure I'm in degree mode for this to work. Okay, so I'm going to take 1/2 times 90 times 52 times the sine of 102. Okay, and we're going to hit enter on that. And this is my answer. Okay, 2288-ish. And the units that are written on your page are meters, so this would be square meters for a measurement of the area. Okay, there are 2 more problems following this that both use the law of sines. If you would like some additional practice, that would be a good place to go. I can put these solutions on Edmodo, or we can check them in class. But you actually are done with the video lesson now, so make sure that you find your problem packet for this unit, and you're working Unit 7, Worksheet 1. And it's not all of the problems on it. Within that worksheet, I just need you to do problems 2, 3, 4, 5, 6, and 8. Okay, so the law of sines worksheet, the very front side has 2 more examples for you to look at, and you have to flip the page and then find where problem 2 begins. All right, thank you so much. See you in class.